Higher Secondary Examination 2015 gi question answer amuk nainasi. Subject Mathematics, full marks 100, pass marks 33, time 3 hours 15 minutes. 15 minutes are given as extra time for reading questions. Attempt all questions. The figures in the right margin indicate full marks for the questions. Ye thangba nakanda lairiba figures sing asina questions sing adugi full marks sing ne. For question numbers 1 to 6, write the letter associated with the correct answer. Question number 1 dagina 6 fawagi damakta di achumba answer adugi chanaba letter adu iyo. Question number 1. For the binary operation asterisk on Z defined by A asterisk B equal to A plus B plus 1, the identity element is A the minus 1, B the 0, C the 1, D the 2. 1 mark. Correct answer is A. As A asterisk E equal to E asterisk A equal to A for any A belongs to Z. A asterisk E is equal to A plus E plus 1, and which is A equal to A. Cancelling A we get E equal to minus 1. Question number 2. If x belongs to R, twice of tan inverse of x is equal to. Defective question. Wang achumba answer yaudi. Question number 3. The derivative of x squared with respect to x cubed is. The correct answer is D. Maram D. X squared ki derivative is twice x. X kuna twice x kakthana twice x squared kakthana si phangani. Next, question number 4. The point on the curve y square equal to x where tangent makes an angle 45 degree with x axis is. Curve asigi karamba point singba tangent na x axis ta 45 degree singba dagi. Curve asidagi dy by dx puthokani madu expression adu tan of 45 ko manahal laga x ki value y ki value solve togani. Correct answer is D. Y square equal to x pu x na derivative lorabadi we get this. Madudi yauriba dy by dx adu 10 45% kara 45% labadi y ki value half hange. Y ki value half percent labadi x ki value 1 by 4. Therefore the point is x ki value 1 by 4 comma y ki value half. The correct answer is D. If f of minus x equal to f of x, then integrand of f of x dx from minus a to a is equal to wahang asi piramiba function ji even function ne even function ki damakta di twice 0 to a twice 0 to a integrand of f of x dx from 0 to a ki twice c asi ka chane. Question number 6. The vector equation of the line passing through 1 2 minus 3 and parallel to the vector this is. Apiba point asi phawba apiba vector siga parallel oiba line gi vector equation adu makhara piba sikaramba chumbage hangmani. Apiba point 1 2 minus 3 sida ij ke na puri rabadi aikoina d asi tarani aduga apiba vector duga parallel oiba haragadi c orani. Correct answer is D. Question number 7. What is meant by inverse of a function? Function namagi inverse have a sip karino. Function namagi inverse. Let f be a function from the set A to the set B, b1 1 and on to function that is bijective function. And if f of x equal to y, where x belongs to A and y belongs to B. Sigi condition sina apiba function adugi apiba function namani bijective oiba function namani fc. S ki mamino y da f of x equal to y oirabadi. Then f inverse f ki mami di f ki inverse di f to the power minus 1 akhanagani. F inverse is a function from b to a defined by f inverse of y equal to x is called the inverse function of f. Question number 8. State the domain and the range principal value branch of the function cosec inverse x. Cosec inverse x ki domain amasung range hayu habani. Cosec inverse x ki domain the domain is r minus open interval minus 1 1 and the range principal value branch is closed interval minus pi by 2 minus set consisting 0 only. Define a matrix. Question number 9. Define a matrix. Mark Amma. A rectangular array of mn numbers in m rows and n columns is called a matrix of order m by n. 10. If y equal to f of u, u equal to z of x, where f and z are differentiable functions, then write the relation between dy by du, dy by dx, and du by dx. 1 mark. The relation is dy by dx equal to dy by du into du by dx. Asumna irasu yai, tongan form singda iba yagani. Masi chain rule kawi khuna. When is a function f of x said to be strictly decreasing function? Strictly decreasing function haibasi karino. A function f is said to be strictly decreasing function in the interval I if x1 less than x2 implies f of x1 greater than f of x2 for all x1, x2 belong to I. A function f is said to be strictly decreasing function in the interval I if x1 less than x2 implies f of x1 greater than f of x2 for all x1, x2 belong to I. Write the integrating factor of the differential equation dx by dy plus p of x equal to q. The integrating factor is e to the power integral of p dy, not dx. Define position vector of a point. 1 mark. Let O be a point in space and P be a given point. Then the vector OP with arrowhead is called position vector of the point P with O as origin. Write the vector equation of a line passing through 2 points with position vectors A vector and B vector. A vector amasung B vector na position vector sing oiba point ani adugi pharo sapal line adugi vector equation puto. The vector equation of the line through 2 points with position vectors A vector and B vector is R vector equal to A vector plus lambda times of B vector minus A vector. Question number 15. Find the direction cosines of the perpendicular from the origin to the plane disk. Origin dagi plane asde singakpa normal adugi perpendicular adugi direction cosine sing puto. The direction cosines of the perpendicular are 3 by root over 3 square plus 6 square plus 2 square and minus 6 by root over this minus 2 root over by this. Simplification. After simplification we get 3 by 7 minus 6 by 7 minus 2 by 7. Question number 16. Write the multiplication rule of probability for two events A and B. 1 mark. The multiplication rule of probability for two events A and B. P of A intersection B is equal to P of A into P of B by A, and P of A intersection B is equal to P of B into P of A by B. Let R1 be a relation in R defined by order pair AB belongs to R1 if and only if 1 plus AB greater than 0 for all AB belongs to R, so that R1 is reflexive and symmetric but not transitive. 3 marks. Here order pair AB belongs to R1 if and only if 1 plus AB greater than 0 for all AB belong to R. Reflexive. For each A belongs to R, 1 plus A into A equal to 1 plus A square, which is always greater than 0. Implies order pair AA belong to R1. Implies R1 is reflexive on R. For symmetric, let A be order pair belongs to R1. Implies 1 plus AB greater than 0. Implies 1 plus BA greater than 0. Implies BA order pair belongs to R1. Implies R1 is symmetric on R. For transitive, let 4 1 by 4 belongs to R1 and 1 by 4 minus 2 belongs to R1 is 1 plus 4 into 1 by 4 greater than 0. Again 1 plus 1 by 4 into minus 2 greater than 0. But 1 plus 4 into minus 2, that is 1 minus 8 equal to minus 7, which is less than 0, never greater than 0. This shows that R1 is not transitive on R. Haibadi 1 4 minus 2 order PR do R1 the yaudi, but R1 is not transitive on R. But not transitive with the counter example or I can prove to one. Hence R1 is reflexive and symmetric but not transitive. Prove that sine inverse of 5 by 13 plus cos inverse of 3 by 5 equal to tan inverse of 63 by 16. Prove that sine inverse of 5 by 13 plus cos inverse of 3 by 5 equal to tan inverse of 63 by 16. 3 marks. Let sine inverse of 5 by 13 equal to A and cos inverse of 3 by 5 equal to B. Implies sine A equal to 5 by 13 and cos B equal to 3 by 5. Sine A is 5 by 13, therefore cos A is equal to square root of 1 minus sine square A. We get 12 by 13. Similarly, sine B equal to square root of 1 minus cos square B. Square root of 1 minus 3 by 5 whole square equal to 4 by 5. That gives tan A is sine A by cos A, whose value is 5 by 12, and tan B is sine B by cos B, whose value is 4 by 3. Now tan of A plus B, if we put A and here we put B, then we get A plus B, and tan of A plus B whose expansion is this. Tan A must tan B value simplified to 63 by 16 implies A plus B equal to tan tan inverse of 63 by 16. A must B original value we get this, which proves the reason. 19. Evaluate integral 1 by 2 plus cos x dx. 3 marks. Cos x in terms of tan x the trigonometric formula then simplify this mataki 1 plus tan square x amuk sec square x by 2 the makana tan x by 2 da matana sec square x by 2 da 10x by 2 the putting torani 10x by 2 c z atopal variable amada putting torani mark derivative t sec square x by 2 aduga amu into half dx equal to dz phangre respective value thamo kon z to change tokare 2 mamang chakro then 3d root 3 whole square ni standard integral ama sadare 2 into 1 by a tan inverse of x by a ge formula paladi si phange z ki value d 10x by 2 ni root 3 lere. Question number 20. Define a differential equation. What are its general and particular solution? Differential equation nama karina ayo mark is general solution karina particular solution karina 3 marks. Differential equation. An equation involving derivatives of the dependent variable with respect to independent variable of variables is called a differential equation. Dependent variable da independent variable natraga variables singna derivative singi derivative sing yauba equation amabu differential equation kawi. Samna derivative sing yauba equation amabu differential equation kawi. General solution. A solution of a differential equation is said to be a general solution of the differential equation if the number of arbitrary constants is equal to the order of the equation. Differential equation amagi solution ama general solution differential equation dugi general solution haigani solution adu the yauriba arbitrary constant masing duga differential equation adugi order masing manarabadi. Particular solution. A solution of a differential equation is said to be a particular solution of the equation if the solution is obtained from its general solution by giving particular values to the arbitrary constant. Differential equation amagi solution se particular solution haigani solution ado mahaki general solution da yawa arbitrary constant sing da particular values sing pisilaga phanga ko oirabadi. If a vector equal to in terms of ijk, b vectors to components in the form that then prove that a cross b is equal to in terms of determinant. We have a cross b is equal to this. Actual distributive property palani a1 I cap na cross torani ani suba vector da plus a2 j cap na mo cross torani ani suba vector da plus a3 k cap na mo cross torani ahum suba vector da a1 na loina cross talk to badi we get this ahanba expression sima phangani then sin amuk the cross talk to badi sigi ahum sima phangani a3 ke kem na amuk cross talk to badi sigi ahum suba underline to riba ahum suba si phangani. We have learned that I cross id 0 vector ne I cross k jd I cross jd k vector ne I cross kd minus j ne j cross id minus k ne j cross jd 0 vector ne j cross kd I cap ne k cross id j ne k cross jd minus I ne k cross kd 0 vector ne I cap yawa vector singdo amuk I cap yawa vector lothokra minus j cap yawa vector tam anidagi minus j kam lothokra si phange k cap yawa tam anidagi khona k cap lothokra si phange. This is the expansion of this determinant whose the elements in the first row are I cap, j cap, k cap, second row a1, a2, a3, third row b1, b2, b3. Hence proof. Question number 22. On a multiple choice examination with 3 possible answers for each of the 5 questions, what is the probability that a candidate would get 4 or more correct answers just by guessing? Multiple choice examination amada question khudingmakta option ahum answer ahum yawe itokpa ba answer ahum yawe question manga dugi. What is the probability that a candidate would get 4 or more correct answers just by guessing? Candidate amana question mari natraga mari degi hen na chumna khungmani haibagi probability putu haiben. 4 marks. Let x be the number of correct answers. X na correct answer gi masing do khangnarasi. Then n equal to 5. Question manga ni adu p di correct answer. Option ahum dugi manung ama khaktani chungmaduri basi multiple choice nina al p gi value da 1/3 q di lana khumbagi probability di question ama lana khumbagi probability di 2/3. Then p of x equal to r success ki di 5c r p gi value di 1/3 power r q gi value di 2/3 power 5 minus r can be 0 1 2 up to 5. The required probability is equal to p of x greater than equal to 4. Question mari natraga mari degi hena khumba haibani, which is equal to p of x equal to 4 plus p of x equal to 5, whose values are mataki formula asidi yawa r asidi 4 sinjilo amuna 5 sinjilo. We get this tam ani sidagi khone expand taro si phange mathak man makha manarabadi mathak tinjinarani. We get 11/243. Kanagumba mana question da mari natraga mari degi hena khungani habigi chance si 11/243 ne. 23. State Rawls theorem and Lagrange's mean value theorem and give their geometrical interpretations. Rawls theorem amasung Lagrange's mean value theorem sing adu eu aduga makhoi gi geometrical geometry gi oiba art sing adu supiramu 4 mark. Definition da mark ani geometrical interpretation da mark ani punna mark mari. Rawls theorem na kari hari. If a function f is defined over the closed interval ab is such that number 1 that it is continuous in the closed interval ab, it is derivable in the open interval ab, and f of a equal to f of b. Condition ahum chi chumlabadi, then there exists at least one point c belongs to open interval ab such that f dash of c equal to 0. Geometrical interpretation of Rawls theorem. Geometry ki oiba arthadi. If a curve representing a given function has a tangent at its points and the ordinates at the extremities a and b are equal, then there exists at least one point c on the curve other than a and b, the tangent at which is parallel to x-axis. Curve amagi point ꯈꯨꯗꯤꯡꯃꯛꯇ ꯇꯦꯟꯖꯦꯟ ꯆꯤꯡꯕ ꯌꯥꯔꯕ n ꯄꯣꯏꯟꯠ ꯑꯅꯤ ꯑꯗꯨꯒꯤ ꯑꯣꯔꯗꯤꯅꯦꯠ ꯑꯅꯤꯗꯨꯁꯨ ꯃꯥꯟꯅꯔꯕꯗꯤ A ꯑꯃꯁꯨꯡ B ꯍꯥꯏꯔꯤꯕ ꯄꯣꯏꯟꯠ ꯑꯅꯤ ꯑꯁꯤꯒꯤ ꯃꯔꯛꯇ ꯌꯥꯝꯗ꯭ꯔꯕ ꯑꯅꯤꯁꯤ ꯅꯠꯇꯕ ꯑꯇꯣꯞꯄ ꯄꯣꯏꯟꯠ ꯑꯃ ꯂꯩꯒꯅꯤ ꯃꯐꯝ ꯑꯗꯨꯗ ꯆꯤꯡꯕ ꯇꯦꯟꯖꯦꯟ ꯑꯗꯨ ꯃꯐꯝ ꯑꯗꯨꯗ ꯆꯤꯡꯕ ꯇꯦꯟꯖꯦꯟ ꯑꯗꯨꯅ x axis-ꯇ parallel ꯑꯣꯏꯒꯅꯤ. Lagrange's mean value theorem. If a function f is defined over the closed interval ab is such that number 1 it is continuous in the closed interval ab and it is derivable in the open interval ab, and then there exists at least one point C belongs to open interval AB such that f dash of C equal to f of B minus f of A divided by B minus A. Geometrical interpretation of Lagrange's mean value theorem. If a curve representing a given function has a tangent at each of its points and the ordinates at the extremities A and B are not equal, then there exists at least one point C on the curve other than A and B, the tangent at which is parallel to the chord joining A and B. Question number 24. If y equal to x to the power x, prove that d square y by dx square minus 1 by y times of dy by dx whole square minus y by x equal to 0. 4 marks. Here y equal to x to the power x. Taking log on both sides, we get log y equal to x into log x. Differentiating on both sides with respect to x, we get 1 by y into dy by dx equal to x into log. Derivative of log x is 1 by x plus log x remains unchanged into derivative of first function, that is x, whose derivative is 1. Therefore dy by dx equal to this. Again differentiating both sides with respect to x, we get this, and for this d by dx of dy by dx, the value of dy by dx is this, and apply product rule. First function remains unchanged, derivative of the second function, whose is 0 plus 1 by x, that is 1 by x, plus second function unchanged, derivative of x to the power x is itself. Simplify, we get this. Therefore left hand side asida respective values in the pisilasi aduga expand toraba matungda we get 0. Hence proof. Question number 24 ki alternative. So that f of x equal to modulus of x minus 5 is continuous but not differentiable at x equal to 5. 4 marks. Piriba modulus function asi 5 to continuous so aduga differentiable di oidi. Proof so. Here this. Continuity at x equal to 5. Left hand derivative at 5 denoted by this f of x is this. But x is less than 5, therefore whose absolute value is minus times of x minus 5, and which is again polynomial, therefore its limit is minus times 5 minus 5, that is 0. For right hand limit at 5 is denoted by this, whose value is x is greater than 5, therefore whose modulus is x minus 5. And put x equal to 5, we get 0. Also f of 5, function value is also modulus of 5 minus 5, that is 0. These three values are equal. Thus limit of f of x at x equal to 5, x tends to 5 from left equal to limit of f of x, x tends to 5 from greater values of 5 equal to f of 5. This shows that f of x is continuous at x equal to 5. First part is over. Differentiability at x equal to 5. 11 derivative at is equal to x plus 5 is less than 5, and therefore whose absolute value is minus x minus 5 plus 5, and f of 5 is 5 minus 5, and after calculation we get minus 1. Similarly right hand limit at 5 denoted by this x plus 5 is greater than 5, therefore whose absolute value is 5 minus is minus 5. After calculation we get 1. These two values are not equal. Thus, 11 derivative at 5 does not equal to right hand derivative at 5. This shows that hence f is not derivable at x equal to 5 or not differentiable at x equal to 5. Question number 25. Prove that integrand of root over x square minus a square dx is this. where a is greater than 0. 4 marks. We have to apply integration by parts. First function remains unchanged into integral of second function minus integral of product of derivative of first function and integrand of second function, for which we get x times of this, and for which we get this. Rearranging this x square to x square minus a square plus a square fill up tawrani. Rearrange to a x square minus a square da root over x square minus a square ni yellabadi we get this. A square does in divide to the minus a square times of 1 by root over x square minus a square there. Sigi integral this lere si I ga manarani si pura full standard pare. Log of modulus of x plus root over x square minus a square. I na sumsakadi twice I equal to this. I implies I give 2 instead divide to the sipange, 2 instead divide to the sipangane. Hence proof. Question number 26. Using integration, find the area of the region in the first quadrant enclosed by the x-axis, the line y equal to x, and the circle x square plus y square equal to 32. Piriba cup asigi graph yekane. For point of intersection ki damakta di circle ki question the yauriba wa x asi y na sindokho maram di y ke x ka mana rabarina solve to rabadi y ki value plus minus 4 phange. Corresponding value su x की value su plus minus 4 और any maram di y के x का मान खिबरिना. Therefore b 4 lere is in this picture. Line adi origin power is in a circle radius 4 oibaduni adu orabadi a की value da 4 root 2 0 lere ni. Sigina b की value na 4 lere origin is 0 0 lere. Sigi perpendicular drop tawrani. Segment ani sigi area da sum puto over matung da required area da phangai. Required area the area of OBC and area of ABC. Area of OBCD cup sig line asina x axis ta 0 dagina x value 0 dagina 4 box semba adugumba result asigi area sini mathangadi circle asina x axis ta x value x equal to 4 dagina x equal to 4 root 2 bokima to semba area adoni. Then we get this. X की x का by 2 लरे सिगी सु formula direct पालनी x की value तो 4 पिछले बड़ी 8 फंगे x की value तो 4 root 2 पिछले 0 फंगनी सीधा पिछले बड़ी we get 16 into pi by 2 लरनी lower limit सिंजंबगी दी और upper calculation में सी फंगनी value सिंगादो calculation तरबो मतुंग द 4 pi square units फंगे. Question number 27. Solve the differential equation. If differential equation is solved to have 4 marks. dy by dx solved to have a homogeneous differential equation. This is a homogeneous differential equation. Put y equal to bx and dy by dx equal to b plus x db by dx. We get b plus x db by dx equal to x minus y gidi bx by x plus y gidi bx x kamaloto kakhanaro. Calculation tawrabadi we get this separation amuk policy db ki mamang b makai thame ds ki mamang s makai thame masi separation of variables ni. Integrating both sides and rearranging we get this. Sigi integral this phangani sig integral slare constant of integration the log si chale log singa si log property policy we get log nakan ani moti ki log kathat khara this phangai. Squaring color is c square root k and thamo which is the required general solution. Question number 27 alternative. Solve the differential equation this. 4 marks. Piramiba differential equation C karama makalgi differential equation ovni yangsi dx by dy plus 1 by of 1 plus y square times of x equal to function of y. This is a linear differential equation. Dependent whose dependent variable is x, independent variable is y. Therefore, integrating factor is e to the power integrand of p dy. P is what? 1 by of 1 plus y square, whose integrand is 10 inverse y. Therefore, the general solution is x into e to the power 10 inverse y equal to this is q into this. Sig integral the polynomial then tan inverse y do aikoina z ta putting tore tan inverse y do z ta putting tore to si phangani sigidi or si phangani z into sigini z lere z e to the power z sigini z e to the power sigidi lere then integration by palo z na first function on a toro e z na second function again we get this z ki original value pisal si z ki original value di z ki di tan inverse y loina pisalani. This gives the required general solution. 28. Using vectors, prove that perpendiculars drawn from the vertices of a triangle on the opposite sides are concurrent. Vector sizinaraga triangle amagi opposite side tagi vertex kudingmaktagi opposite side singapa perpendicular singdu opposite side singapa perpendicular singdu concurrent oy habu ulu point amada unai ulu. Let in triangle ABC BE perpendicular to BE perpendicular to AC and CF perpendicular to AB. Let BE and CF intersect at P. P the kakna hale. Join A P ga P ga samjinarasi and produce to meet BC at D. BC B una hale. Now we have to prove that AD is perpendicular to BC. Let A vector, B vector, C vector and P vector be the position vectors of A, B, C and P. Since BE is perpendicular to AC, therefore BP vector perpendicular to AC vector implies BP vector is P vector minus B vector. Perpendicular is dot 0 ni. AC vector is C vector minus A vector equal to 0, which is equation 1. And CP is perpendicular to AB. Implies CP vector is perpendicular to AB vector. Their dot is also 0. This is equation 2. From 1 and 2, we left ani se right ani se mana radi left ani mana hale expand or ani kona expand or simplify or we get this. From si pange CD, which is what this is what AP vector, this is what BC vector. Vector ani ki dot to 0 tarabadi. Dot to 0 or AP vector dot BC vector. The AD vector perpendicular to BC vector. Using elementary transformations, find the inverse of the matrix. This sige matrix sige inverse to elementary transformation sizinaraga 6 mark. Using elementary transformation, find the inverse of the matrix. This. Let A equal to given matrix. We have A equal to I into A. A की value पिछले I की value पिछले A असी I unit matrix of third order से ताना बसिंसी. First row का second row का interchange तोनोरा we get this. Next. First row असी ना second row दा तिंजिला अदोगा first row असी 3 times तो ना third row देखी खाई दो new first row when simuk phangani third second first row dileng na thamani second row du hongani third row su hongani sumna 1001 3 ge jaga da 1 tahan ge hairabadi second row sida koina 2 no purira sida 2 no purira badi we get first row musung third row dileng na thamasi. Next third row second row sidi the second row the third row second row the third row tinjila we get new second row si phange first row amasung third row di lengdana leirani mathang da second row the 5 na puri raga third row the tinjila si we get new third row first row amasung second row di lengdana thamani. Next 2 na divide to thokoro third row the all third row the 2 na divide to thokoro si phangani mathang da first row the 3 times of third row na khaido khoro second row the 2 times of third row khaido khoro we get this. Next second row the 2 no piraga first row the khaido khoro we get unit matrix phangani adu orabadi matrix ani ge product na I tarabadi matrix amado A ga purineba matrix to A inverse ki value or A with value sure. State 3 fundamental properties of a determinant and show that this determinant is 2 times of x plus y plus z whole cube 6 mark. Three fundamental properties of a determinant. 1. The value of a determinant remains unchanged if all rows and columns are interchanged. Determinant amagi row khudingmak column khudingmak pham onthoknarabadi determinant value hongde. Property 1. The value of a determinant is 0 if two rows are identical. Determinant amagi row ani manarabadi magi value 0 ni. Ahumsuba property number 3, that the sign of a determinant is changed if two rows are interchanged. Row ani interchange torabadi determining is sign change toy. Next, second part, we have to prove this determinant. Second row, first column, the second column, third column, hapchalasi, we get new first column. Sidagi 2 times of x plus y plus z lawthokrabadi 1 ngakang lehore. 0 yamna phangnanaba first row dagi second row khaidokrasi. First row dagi second row khaidokrabadi new first row dusi phangani, new second row third row di remains unchanged. Third row da first row expand tokhosi, expand tokhobadi mahakidi minus amala alakani ko factor hanagi minus kadi plus larani. Hanagi amala di square ka khare asumna mahak yauba first row siga second column siga lawthokrabadi. Si lawthokrabadi we get 1 z plus x plus twice y minus 1 into y khaidokrabadi 2 times of x plus y plus z whole cube phangani. If the sum of the length of the hypotenuse and a side of a right triangle is given, right triangle amagi hypotenuse ka side amaga anigi ashangbagi sum adu piramlaba, so that the area of the triangle is maximum when the angle between them is pi by 3. Triangle ki area adu maximum oige hairabadi side adu ka hypotenuse ki marak ki angle do pi by 3 oigadabani utlu. In right triangle ABC, AB is y, BC is x, angle ABC is theta. Area of triangle ABC is A, that is half times of base is x, and altitude BAC is square root of y square minus x square. By question x plus y is equal to k, it is given. From 1, squaring on both sides we get this, for this we get this, and 1 by 4 x square, y square की value दी k minus x whole square, and a square to z and putting tawre 1 by 4 lere x square na position garo si the kaptana ramatunda we get this. Now z is function of x, dz by dx x na derivative or amuk so c x na derivative or c phangane. For maximum dz by dx to 0 the putting taroni x equal to k by 3 phangane. At x equal to k by 3, second order derivative is this minus k square by 2 less than 0. Z is maximum when x equal to k by 3 and y equal to twice k by 3. Therefore cos theta is x by y equal to half, equal to cos of pi by 3, implies theta equal to pi by 3. Third question number 31, alternative. Water is running into a conical basin 15 centimeter deep and 5 centimeter in radius at the rate of 0.1 centimeter cube per second. When the water is 6 centimeter deep, find at what rate is the water level rising, the weighted surface of the basin increasing. 6 marks. In figure, r equal to O dash A dash sina r ohelani, then B dash A dash asina ice ohelasi, B dash ka A dash kana ice ohelasi, B dash O dash na ice, B dash A dash na slant height L ohelasi. OA asidi fix ni 5 cm ni, aduga amuksu o B dash ka O ga sig awang 15 cm ni, angle AB dash O sig angle asi alpha one lawrasi sig centimeter si small centimeter ogadam. Now R by H, R, this is R, this is H, this is R, this is H. R by H is what? 5 by 15, that is 1 by 3. That is H equal to thrice R, which is equation 1. And slant height, this slant height L to the R square plus H square, which is equation 2. From 1, volume the V 1 by 3 pi R square H. H is what? H is thrice R. Therefore, we get this. R value the H by 3, whose value is this. Now V is in terms of H. dV by dt. Differentiating both sides with respect to t. We get dV by dt pi by 27 I cubed with the thrice I square I dH by dt equal to dV by dt is 0.1. This we get dH by dt equal to 9 by 10 pi I square. When I is equal to 6 centimeter, dH by dt equal to 1 by 40 pi meter per second. Now Roman number 2, weighted surface area the slant height to ni S equal to pi RL. R dH by 3 pirani slant height the Pythagoras theorem relation degi puthoni, we get this, and then R C D H by 3 pisalaga in terms of H the fondo A. ds by dt, ds by S t derivative both sides to log. For this we get this. Respective value pisal when I is equal to 6 dI by dt and 1 by 40 pi, the value of ds by dt is after calculation root over 10 by 30 centimeter square per second. To evaluate integral of log of cos x dx from 0 to pi by 2, 6 marks. Let I equal to this definite integral. Also, I could be using properties 0 to a. Cos is replaced by pi by 2 minus x. Cos of pi by 2 minus x is sin x. Using 1 and 2, we get twice I equal to this plus this. And taking log we get this. And with this, which is log 2, and whose value is this. Twice x to theta putting toro, we get this half common log, limit change torani. Simplify to I minus this. I both sides I log to cross some C value fange I value pixel loss siller. (32) alternative evaluate the value of this definite integral. 0 to a property palani x to pi minus x could remove pi minus x in the lani expand the C fangani. Then twice I C pi akon bagi minus I the sum transfer to kro I lere C pi square ki tamama fangani. C pi ki amalani no pi the constant ni dx by a square minus cos square x. 2 mamang sakro pi C 2 times of pi by 2 ni 2 mamang sakro 2 mamang song gabi maramdi C ki cos x to pi minus x in the lusu cos of x return to pagini. Nakan animakta ki 2 log thokra de I equal to pi times of this. C found C property is palabadi. Cos square x na mathak makha to yen ba natraga sec square x na mathak makha purirabadi, we get this makha ki sec square is 10x 10 square x na sadokro identity sinaraga. Next 10x to theta the putting taro 10 ki derivative is sec square dx d theta larani when x equal to 0 pi by 2 theta equal to 0 infinity respectively 0 infinity pishalani sinjalaba matungda si ole. Then makha si quadratic equation in theta the semani theta yaba tamal the perfect square changalani. Then see the proper standard formula phare 1 by 8 10 inverse of theta by a limit panchalaga si phangani. Hence find out. 33. Define skew lines and the shortest distance between two skew lines. Skew lines sing have karino skew lines sing marakta laiba khwaidiki nakfara apadu karino define to. Find the shortest distance between two given lines. Line ani ki marakta laiba shortest distance adusu puto 6 mark. Two lines are said to be skew lines if they are neither intersecting nor parallel. Karigumba line ani kak sukakna draba parallel suidraba ani mak oidraba di skew line sing kawi. By the shortest distance between two lines, we mean the join of a point in one line with one point on the other line, so that the length of the segment so obtained is the smallest. Let L1 and L2 be two skew lines with equation this and this. Take any point S on L1 with position vector A1 and T on L2 with position vector A2. Then the magnitude of the shortest distance vector will be equal to that of the projection of ST along the direction of the line of shortest distance. If PQ vector is the shortest distance vector between L1 and L2, then it being perpendicular to both B1 and B2. The unit vector n cap along PQ would be n cap to B1 cross B2 divided by whose magnitude. Then PQ vector equal to D times of n cap, where D is the magnitude of the shortest distance vector. Continued. Then PQ vector is D times of n cap vector, where D is the magnitude of the shortest distance vector. Let theta be the angle between ST and PQ. Then ST into modulus of PQ vector dot ST divided by magnitude of PQ vector into ST vector. PQ is equal to ST is equal to this, PQ is equal to DN vector. Put their respective values. We get cancelling ST. Hence the required shortest distance is D, which is equal to this. Question number 33. Or find a vector equation of a plane passing through a given point and perpendicular to two given planes. Apiba point plane anida apiba point ama phauba apiba plane anida perpendicular oiba plane equation of the vector da putu deduce the Cartesian equation of the plane adugi equation of the Cartesian form da su puthoklammo 6 marks. Let a vector equal to a1 x1 y1 z1 be the given point, and r vector dot n1 vector equal to q1 and r vector dot n2 vector equal to q2 be the two given points. Let n vector be a vector perpendicular to both the planes, then n vector equal to n1 vector cross n2 vector. Therefore, the vector equation of the plane passing through the point A and perpendicular to the planes this and this is r minus a vector dot n1 vector cross n2 vector equal to 0. Let a vector equal to x1 y1 z1 be the given point and the planes be this and this. The equation of the plane is this, and which is the scalar triple product of three vectors. Their value is given by this determinant. Question number 34. A manufacturer makes two products A and B. Product A sells at rupees 200 per unit and it takes 30 minutes to make. Product B sells at rupees 300 per unit and takes 1 hour to make. There is a permanent order of 14 units of product A and 16 units of product B. A working week consists of 40 hours of production and the weekly turnover must not be less than rupees 10,000. If the profit on each unit of product A is rupees 20 and on product B is rupees 30, then find how many units of each product should be produced to get maximum profit. Solve the LPP graphically. No graph paper will be supplied. Manufacturer amakana product A haibamuga B haibamuga sai product A aduna unit amadu lupa sanidi yoli saba matamda minute kuntra changi. Product B na unit amada lupa chahumda yoli aduga saba matamda pung ama changi. Unit sing asi A amasung B asi 14 units amasung 16 units mathang sina order permanent order lay. A working week consists of 40 hours of production. Hafta amada phangiba se 30 or 40 hours ni, and the weekly turnover must not be less than 10,000 rupees. 10,000 dagi hena turnover must not be less than mahaki hata amagi lakpa sendong silising tara dagi tahaloi dabani. If the profit on each unit of product is rupees 20, product A gi unit amagi lupa kun tongi adu product B gi lupa kuntra tongi. Then find how many units of each product should be produced to get maximum profit. Sendong hena laknabagi damak unit anima kaya sagadagi graph ki mateng solve to graph paper is apply to piro. Let x and y be the number of product A and B. Then the problem is to maximize z equal to 20x plus 30y. Subject to the constraints, makoi singadudi amada sulfatani piradi x adi 200x. Product B amagi unit amada wa alpha chahum pirabadi adugumba y di 30y. Animakta pulapana invest of theory which must be greater than or equal to 10,000. 10,000 dagi tahalloi dabari. Then simplify the receipt fangani and half of x plus y should be less than or equal to 40. Similarly, x greater than or equal to 14, y greater than or equal to 16, and x greater than or equal to 0, y greater than or equal to 0. Masi we kona formulate to kawi. The graphs of the corresponding equation 1, 2, 3, 4, 5, 6 are the lines. Ahan bagisina AB korosi, ani subasina CD korosi, ahum subasina EF, mari subasina GI, manga suba x equal to 0, the y axis ni, and the y equal to 0, the x axis ni respectively, as in this picture. The study region ACDB with vertices A2616, C4816, D1433, B1424 is the feasible region. At AZ equal to this, at CZ equal to this, at DZ equal to this, at BZ equal to this. Thus, the maximum profit is rupees 1440 when unit of product A is 48 and that of B is 16. Question number 35. Bag A contains 3 red and 4 black balls and bag B contains 4 red and 5 black balls. 2 balls are transferred at random from bag A to the bag B and then a ball is drawn from bag B. The ball so drawn is found to be red in color. Find the probability that both the transfer balls were black. Bag A amasung B da ball machu ani gi ball sing yawe ahanba bag A dana angangba ahum amuba mari bag B dana angangba mari amuba manga yawe. Bag A dagi ball ani transfer tawi bag B da adugumba bag B dagi ball ama laukhale angangbo oina phange. Ahanba laukhatkiba transfer tawkiba ball animaktu black oigani haibagi probability kayano 6 mark. Let H1, H2, H3 be the events of drawing 2 red balls, 2 black balls and 1 red and 1 black balls. This must be black balls. From bag A and transferred to bag B. Let E be the event of drawing 1 red ball from bag B. Then P of X1 day. Bag 1 da angangba ahumni madudagi ani lokhatna angangba oigani haibasidi 3C2 ni out of ball 7 ni yaw 7C2 ni yelani 1 by 7 phange asumna bag 2 dagi aikoina black ani lokhatpagi oragadi ahan bag da black mari ni 4C2 by 7C2 magasu 2 by 7 phange ahan bag dagi black ama red ama lokhalaba su yai ball ani do hariba cases sing oigani 4 by 7. P of E by H1, P of E by H1 6 by 11, P of H2 4 by 11, P of H3 5 by 11. The required probability is P of H2 by E base theorem palagat si phange respective value pishalani simplified tare we get 4 by 17. Bag A dagi bag B da transfer takiba ball animak angangbo oigani amubo oigani haibagi probability is 4 by 17. Theta yaba tamal the pape square changalani. Then see the proper standard formula pare 1 by 8 10 inverse of theta by A. The limit panchalaga si phangani. Hence find out. 33. Define skew lines and the shortest distance between two skew lines. Skew lines sing have a karino skew lines sing marakta laiba khwaidigi nakpara apadu karino define to. Find the shortest distance between two given lines. Line ani gi marakta laiba shortest distance adusu puto 6 mark. Two lines are said to be skew lines if they are neither intersecting nor parallel. Karigumba line ani kaksu kaknadraba parallel suidraba animak oidrabadi skew line sing kawi. By the shortest distance between two lines, we mean the join of a point in one line with one point on the other line, so that the length of the segment so obtained is the smallest. Let L1 and L2 be two skew lines with equation this and this. Take any point S on L1 with position vector A1 and T on L2 with position vector A2. Then the magnitude of the shortest distance vector will be equal to that of the projection of ST along the direction of the line of shortest distance. If PQ vector is the shortest distance vector between L1 and L2, then it being perpendicular to both B1 and B2. The unit vector n cap along PQ would be n cap to B1 cross B2 divided by whose magnitude. Then PQ vector equal to D times of n cap, where D is the magnitude of the shortest distance vector. Continued. Then PQ vector is D times of n cap vector, where D is the magnitude of the shortest distance vector. Let theta be the angle between ST and PQ. Then ST into modulus of PQ vector dot ST divided by magnitude of PQ vector into ST vector. PQ is equal to ST is equal to this, PQ is equal to DN vector. Put their respective values. We get cancelling ST. Hence the required shortest distance is D, which is equal to this. Question number 33. Or find a vector equation of a plane passing through a given point and perpendicular to two given planes. Apiba point plane anida apiba point ama phauba apiba plane anida perpendicular oiba plane equation of the vector da putu deduce the Cartesian equation of the plane adugi equation of the Cartesian form da su puthoklammo 6 marks. Let a vector equal to a1 x1 y1 z1 be the given point, and r vector dot n1 vector equal to q1 and r vector dot n2 vector equal to q2 be the two given points. Let n vector be a vector perpendicular to both the planes, then n vector equal to n1 vector cross n2 vector. Therefore, the vector equation of the plane passing through the point A and perpendicular to the planes this and this is r minus a vector dot n1 vector cross n2 vector equal to 0. Let a vector equal to x1 y1 z1 be the given point and the planes be this and this. The equation of the plane is this, and which is the scalar triple product of three vectors. Their value is given by this determinant. Question number 34. A manufacturer makes two products A and B. Product A sells at rupees 200 per unit and it takes 30 minutes to make. Product B sells at rupees 300 per unit and takes 1 hour to make. There is a permanent order of 14 units of product A and 16 units of product B. A working week consists of 40 hours of production and the weekly turnover must not be less than rupees 10,000. If the profit on each unit of product A is rupees 20 and on product B is rupees 30, then find how many units of each product should be produced to get maximum profit. Solve the LPP graphically. No graph paper will be supplied. Manufacturer ama khana product A haiba amaga B haiba amaga sai product A aduna unit amada lupa chani di yoli saba matamda minute kunthra changi. Product B na unit amada lupa chahumda yoli aduga saba matamda pung ama changi. Unit sing asi A amasung B asi 14 units amasung 16 units mathang sina order permanent order lay. A working week consists of 40 hours of production. Hafta amada phangiba se 30 or 40 hours ni, and the weekly turnover must not be less than 10,000 rupees. 10,000 dagi hena turnover must not be less than mahaki hafta amagi lakpa sendong silising tara dagi tahaloi dabani. If the profit on each unit of product is rupees 20, product A gi unit amagi lupa kun tongi adu product B gi lupa kuntra tongi. Then find how many units of each product should be produced to get maximum profit. Sendong hena laknabagi damak unit anima kaya sagadagi graph ki matengna solve to graph paper is apply to piro. Let x and y be the number of product A and B. Then the problem is to maximize z equal to 20x plus 30y. Subject to the constraints, makoi singadudi amada sulfatani piradi x adi 200x. Product B amagi unit amada wa alpha chahum pirabadi adugumba y di 30y. Animakta pulapona invest of pasadi theorem which must be greater than or equal to 10,000. 10,000 dagi tahalloi dabari. Then simplify to receive fangani and half of x plus y should be less than or equal to 40. Similarly, x greater than or equal to 14, y greater than or equal to 16, and x greater than or equal to 0, y greater than or equal to 0. Masi we kona formulate to bokawi. The graphs of the corresponding equation 1, 2, 3, 4, 5, 6 are the lines. Ahan bagisina AB korosi, ani subasina CD korosi, ahum subasina EF, mari subasina GI, manga suba x equal to 0, the y axis ni, and the y equal to 0, the x axis ni respectively, as in this picture. The study region ACDB with vertices A2616, C4816, D1433, B1424 is the feasible region. At AZ equal to this, at CZ equal to this, at DZ equal to this, at BZ equal to this. Thus, the maximum profit is rupees 1440 when unit of product A is 48 and that of B is 16. Question number 35. Bag A contains 3 red and 4 black balls and bag B contains 4 red and 5 black balls. 2 balls are transferred at random from bag A to the bag B and then a ball is drawn from bag B. The ball so drawn is found to be red in color. Find the probability that both the transfer balls were black. Bag A amasung B da ball machu ani gi ball sing yawe ahanba bag A dana angangba ahum amuba mari bag B dana angangba mari amuba manga yawe. Bag A dagi ball ani transfer tawi bag B da adugumba bag B dagi ball ama laukhale angangbo oina phange. Ahanba laukhatkiba transfer tawkiba ball animaktu black oigani haibagi probability kayano 6 mark. Let Ice1, Ice2, Ice3 be the events of drawing 2 red balls, 2 black balls and 1 red and 1 black balls. This must be black balls. From bag A and transferred to bag B. Let E be the event of drawing 1 red ball from bag B. Then P of X1 day. Bag 1 da angangba ahumni madudagi ani lokhatna angangba oigani haibasidi 3C2 ni out of ball 7 ni yaw 7C2 ni yelani 1 by 7 phange asumna bag 2 dagi aikoina black ani lokhatpagi oragadi ahan bag da black mari ni 4C2 by 7C2 magasu 2 by 7 phange ahan bag dagi black ama red ama lokhalaba su yai ball ani do hariba cases singsi oigani 4 by 7. P of E by Ice1, P of E by Ice1 6 by 11, P of Ice2 4 by 11, P of Ice3 5 by 11. The required probability is P of Ice2 by ini base theorem palagat si phange respective value pishalani simplified tare we get 4 by 17. Bag edagi bag B da transfer takiba ball animak angangbo oigani amubo oigani haibagi probability is 4 by 17.